Hey everyone, welcome to problem number 10, regular expression matching. Okay, so given an input string S and pattern P, implement regular expression matching with the support for dot and star, where dot matches any single character and star matches 0 or more of the preceding element. The matching should cover the entire input string, not the partial. So what are the examples given? So S is equals A and P equals A, then it would return false. Why? So we ran out of the pattern, that's why. If S is A and B is A star, then output should be true, that is okay. AB and dot star, it should also match to true. Okay, this is a hard difficulty one. What are the constraints? So S dot length goes from 1 to 20, P dot length goes from 1 to 20 as well. S contains lowercase English letters, P contains lowercase dot English letters and dot and star, and it is guaranteed for each appearance of star there will be a previous valid character to match. Okay, fair. So let's jump into this one. It's a little bit tricky, but before actually jumping into this one, there is a small question I have for all of you. So imagine there are two strings A and B, and they get so big as in terms of the memory that let's assume we have this computer where all we can do is check only one character of the string at a time, and we have to find out whether string A is equal to string B or not. So what do I mean? So say S equals AAA and T equals AA. You cannot do S equals T, that would return false, because say we have a system which can only check one character at a time. So how would you do it? Of course, there's a way to go through say you have two for loops, check for S, check for T, and then go forward from there. But then there is a very tricky but useful and handy trick that I would want you all to know. So I would write something like check for equal, and it will take in A and B as strings. So say we start matching character by character, and we ran out of A and not B. Oops. So we would want to return true because we ran out of both. Fair. If say not A and B, so we ran out of B and not A, then we would return false. Else, sorry, elif nor sorry A and not B, return false. Else, so we will just check the first element. Oops, 0 equals B of 0, and check for equal, and we will pass everything from the first index of A and first index of B. See what I did there? So basically I'm just checking one, so 0th index, and everything I'm kind of making like a recursive call to from the index ones to both. So let's just check for S and T. Of course it would be false, so say we have R equals AA. Let's check S and R. Whoops, what is this? What do we have for S? Oh, okay, so let's R equals AAA. Let's see. Fair. So why did I go about doing it? Because anyway, for this example, we have to do it every character by character. Fair. How would you do about it? Now this line should ring a bell for you. So it says the matching, sorry, this one, star matches 0 or more of the preceding element. So or gives us choice. And when we are given choice, we'll stick with the tree. So say we have this as a string a b, and our pattern is a star b. Then what it says is either we can take the previous element of the star, or we can just skip it and go to the next. So that's why it would kind of come out as a tree. So either we would repeat the character again, or we would just ignore the character beforehand and just take B, right? Again, from here you would make two choices. So it would be AAB or simple AAB. Okay, like that. Fair? And then here it would match with the given string and you would return true. So a couple of things. Any of these values match with the given string, then we would return true. Okay, let's jump about it. Pretty straightforward depth first search in the tree. So let's say it takes in I and j as the indices. So say if we ran out of I and j both. So if, okay, let me just do this. So length of s and j is also equal to length of p is greater than or equal to, then we would want to return true. So we ran out of both the strings, right? Pretty much the same thing as we did here, right? That's why I kind of wanted you to walk you through that example. Say we ran out of, so there is a string s and we ran out of the pattern, then we would want to return false. Agreed? So then then it would return false. Now how would you check if there is a match? So how would you know if this string kind of matches this string? So the first match is if string s of I matches p of j. I and j are two pointers for string and pattern, if I haven't mentioned it earlier. Or if there is a dot, that's what it says, right? It matches the single character. So p of j is equals a dot. Here I could still run out of I can still run out of the length of the string. So we would make a check here that I is strictly less than s. With me, I know it's a tricky one, it's a lot to take in, so let's see how we can starting to code about it. How would you check in the pattern if there is a star in it? How would you check? So here it says that it is guaranteed for each appearance of star there will be a previous valid character. So I'll just do something like if p of j plus 1, pattern of j plus 1 equals star, and to have this successfully there, I have to just check if j plus 1 is less than s. Oh, less than p, my bad. And this one. Fair? So that gives you a complete idea of checking for star. So now what if we have a star? Again, it gives us two choices, whether to repeat the character or whether to not. So in case if we decide to repeat the character, that is the jth index, then what would we do? So we would just do dfs of, we will keep I the same. Oops, I well, let's just do this way. What if there is, let's say if we don't decide to repeat the character, then what are we doing now? So I is currently here at a, I plus 1 is star. Then what are we gonna do? We'll just shift I by 2, so, sorry, j by 2. Fair. So here j is at a, then j plus 1 is star, and j plus 2 is b. So if we decide to not repeat the character, then we are basically jumping and putting j equals j plus 2. Fair. And what if we decide to, and there will be or condition, because we would want to return either of these two true. So what if what if we decide to repeat I? Then what are we going to do here is we will just start matching for I plus 1 and keep the j same. I plus 1 as in we'll start seeing I plus 1, I plus 2, and the entire pattern. So j plus 1, j plus 2, j plus 3. So we'll keep j the same, and we'll start incrementing pointer by pointer by one, okay, with me. But how would we know this will only trigger if there is a match on first character, right? So we would, if the first character itself doesn't match, no point going down the tree, right? So that's why I added this match condition, and this will all go in one, and this will just return. Okay, with me? I think that's pretty much it. And say the next character isn't a star, then we would just do, if there is a match between the first character, then we would just return I plus 1, j plus 1. So we'll just start sliding this window one by one. Okay, let's see. And oops, okay, let me just make a quick check. Oops. And what if there is no match at all? We would return false at the end, and we would return DFS of 0, 0. I know it's a lot to take in, but if we start going line by line, the code kind of makes sense. Oops. Ooh, return is outside, my bad. Okay, fair. Let's see, let's submit it. There is a time limit exceeded, but code kind of did surprisingly well. Easiest way to handle time limit exceeded, if you have well, the optimization tricks are of course the dynamic programming, so we can actually see if we can improve it with the DP. So we'll do cache if I comma j in cache, and we will just return cache of I comma j. Here we would just save cache of ij equals true, and then we'll return cache of ij. Here we will return cache of ij equals false, return cache of ij. Some easy, it's the easiest way to kind of go about it. Here what we can do is cache of ij equals false, return cache of ij, and let's see, and what we can do here is assign this here and return cache of ij here. And cache of ij equals dfs of this. Okay, let's give it a try. Oops, my bad. Okay, and that clears all the cases. Perfect. I know it's a lot to take in. Hard problems are a little bit tricky. But yeah, as I would say, just start going line by line, couple of tricks that you would want to keep it handy with you all the time. So for more such tricks, stay tuned in. Thank you so very much for watching.